Welcome, everyone. Welcome to this session on building materials of the future and the role that they can play addressing climate change. I'm Justin Worland. I'm a senior correspondent at Time Magazine, where I write about climate change. And I'm thrilled to be hosting this really excellent panel with excellent speakers. Before I introduce them and we get into the discussion, I just want to ask a question just from the audience to get a sense of where people are. How many here have heard the term embodied carbon? So about half. How many of you who raised your hands had heard it 3 years ago? So a smaller number, okay. So this is a really interesting time to be having this discussion, and we're going to get into the basics, then we're going to go into deeper detail as this issue becomes more and more relevant. So just to introduce our panelists, we have Margaret Hansbrough, who's the principal of Third Coast Climate Solutions and an advisor on industrial decarbonization and the climate crisis. And then we have Robert Niven, who's the founder, chair, and CEO of CarbonCure, which produces carbon dioxide removal technologies for the concrete industry. And then finally, Michael Green, who's a principal at Michael Green Architecture, a Vancouver-based architecture and design firm he founded in 2012. And so I want to start with you, Margaret, just again at the sort of basic level to explain to everybody what is embodied carbon and why is it so important, and then also to give a little bit of introduction to your area of expertise, which is steel. So.
Yeah, great. Hello, everybody. Thanks, Justin, and it's good to be with Rob and Mike here today, and on such a beautiful, warm, balmy day in Aspen. It's not a bad setting to go to work. So I'll explain a little bit more of what we talk about when we talk about embodied carbon, specifically in the built environment. And other folks sometimes refer to it as upfront carbon, and why it's such a big deal. We've made huge progress in terms of the operational carbon of buildings, right? Everybody knows energy efficiency, codes, clean energy. You know, we can make a net zero building from an operational standpoint. And that wasn't possible 30 years ago, now it is. And now it's become more and more the norm or the code, right? Particularly here in the US and Europe and other places where it's pretty far advanced. But we really barely scratch the surface when it comes to the embodied carbon, upfront carbon in the materials in the built environment itself. And we're talking about things like steel, concrete, and aluminum, for example. So in the session description, I think it said around 12% of emissions are from construction, roughly. To put that in perspective, the US is about 11% of all global emissions. So this is an enormous part of the global economy, just massive. There's an excellent organization called Architecture 2030, who some of you may know about, and they've driven a lot of change within architecture and within the AEC community. So they have a lot of really good groundbreaking work in this area. And so they estimate that 3 materials, steel, concrete, and aluminum, account for about 23% of CO2 emissions from new construction. That is a quarter of all emissions. A quarter of all emissions. So when we're talking about embodied carbon and building materials, this is the ball game, folks. And it's a very near-term ball game, not a long-term ball game. So they've also projected that between 2020 and 2040, about 57% of emissions are going to be these embodied emissions, not simply the operational carbon in the built environment from new construction. And if you narrow it further, between 2020 and 2030, so what do we got? 7.5 years? 7.5 years? Raise your hand if you know a 7.5-year-old, right? How short of a time span is that? We are talking about 72% of emissions from new construction. That is 3/4, roughly, so that's definitely the whole ballgame. And that's what we call a carbon bomb. And some of you, hopefully more of you after this, will hear it ticking every single day after this. And we have to defuse it incredibly quickly. So I'll pause there, and I'll talk about steel now. So what's the big deal about steel? You probably read a few articles, seen a few headlines. Primary steel, if you didn't already know, is made with coal. You may know coal, pretty bad for the planet, right? We're pretty familiar with that. That much is assumed. So that's the majority of steel production still on the planet, is that primary steel. And steel as a sector is about 11% of CO2 emissions, about 8% of GHG emissions. So again, just on its own, standalone, as much as the United States. And why? Because yes, it's very carbon intensive, but it's also probably one of the most ubiquitous, next to concrete and cement, one of the most ubiquitous materials on the planet, right? It's everywhere. It's responsible for everything that got you here today, everything in your modern life, everything we term, modern living, right? And it's really genius stuff. And we're gonna need still a lot of it in the future if we wanna actually succeed at a clean energy transition. Talking about wind turbines, electrification, EVs, all of it. Steel's gonna be really important. So it's not like you can just get rid of all of it. You have to improve upon it. So the good news here is about 30% of steel globally is electrified. So we melt scrap with a lot of electricity. If you clean up that electricity, awesome, right? So it's not, hopeless, right? We've been doing that for quite a while. And it's about inverse of that globally, so or locally. So in the US, it's about 70% of our steel is electrified. So that's great news. That means also that the US has a competitive advantage. Why? Because we can produce really low, and already do, produce low embodied carbon steel. And we'll talk about that later, but that's a huge geopolitical advantage in my perspective, and I think most people's. The bad news, still about 70% is this primary production using coal. But we made humongous strides, particularly in the last 3 years. The Swedes have just come out with the project in the last 3 years, starting around 2016. It's called Hybrid. Probably read about it, probably saw that picture of John Kerry about a month ago in Sweden in front of a big Volvo construction vehicle made out of green steel. And what they've done there is they've created a kind of a series of pilot projects where they're using green hydrogen to produce steel, to replace coking coal. So there's about a dozen or more pilot projects kind of like this at various stages of the production all around the world, figuring out how do we replace the coal for the most part. There's also a mix of existing technology like direct reduced iron and iron making, or DRI as you may have heard of it. So there's existing and new technologies that we can use to combat these emissions in steel. But we have to go from pilots to large-scale commercialization in just a few decades, right? And we have to be at commercialization in all the key economies around the world by 2030. Again, 7.5 years. And particularly in Asia, where 80% of the steel is produced and consumed. I'll pause there.
Great, okay. Great to have the overview and to get a sense of the picture with steel. And then I'd like to turn to Rob to give us a sense of the picture with concrete.
Yeah, thanks a lot, Justin. Pleasure to be here. My first time to Aspen. I got to say, it's a pretty amazing spot. I enjoyed the nice run this morning as well, so thank you for having me. So if you look all around you, just about anywhere, you'll see concrete. It's really the foundation of society. Apart from water, it's the most consumed product on the earth, relatively speaking as well. If you were to take everything else that we make on the planet, apart from water, it's still less than how much concrete we make every year. So enormous, enormous industry that's operating on every country, anywhere typically where there are people living, there's concrete being produced. So huge industry, so that also comes with a huge environmental footprint. But concrete is made with cement, so if you learn anything from me today, know that concrete and cement are different. Cement is the powder that is used as the glue that goes into concrete when it's mixed with aggregate and water to form a building material. Don't worry about it if you don't understand it. My mom is still learning after 12 years of trying to figure this out. There's a process that's required to turn limestone into cement. It's called calcination. And all of the wonderful work that we've been hearing about decarbonizing the energy industry or decarbonizing fossil fuels and energy transition is not going to have that big of an impact to this industry. And that's because most of the emissions, 2/3, are related to this process. That has nothing to do with energy. Only a third of that is to do with the energy. That's the maximum benefit you can have. It's this inherent process called calcination. And multiply that by the sheer scale of this industry, you have a big, big challenge. Concrete and cement attribute to about 7% of global emissions. And it's also the primary contributor to the embodied CO2 of buildings. So not the energy use of buildings, but all of the CO2 emissions that are released from creating the materials. So this is a massive challenge. And I started out on this journey to see how I could turn that massive challenge into an opportunity. Seize the advantage of an industry that is unparalleled in scale and be able to make impacts within that industry so that we can also have highly scalable, massive impact on the climate and from a positive perspective. So the way that we did that is based on some research that I was doing at McGill University, is you can actually use CO2 to make concrete. And there's a way of doing that that you actually keep the price of concrete the same, you improve the strength by about 10 or 20%, and you lower the carbon footprint. So we started on this journey and started off in Halifax, Nova Scotia, and then now it's operating in 27 countries and over 600 plants around the world. But we're just scratching the surface. There's 125,000 plants that we need to retrofit and start consuming CO2. But motivate them to do that because they can save money and they can save the planet. But I haven't met too many concrete producers where saving the planet is their primary purpose. But that's okay, I don't care, just as long as they're decarbonizing. So our goal is to grow as fast as we can and working with partners, entering into, you mentioned the emerging markets. That's really where all the concrete's being poured. It's not in Aspen, it's not in US. That's where we have to have an impact. And then also expand our technology base, working with other ways that we can use CO2 productively to make concrete, like you can use CO2 to make aggregates. You can also use CO2 to treat all the waste products from this industry. So in a circular fashion, they can be reused instead of extracting virgin materials like water and aggregates. So there's lots of different ways that CO2 can actually be a cure for this industry's CO2 problem. And that's what CarbonCure is all about. But we represent only one company within a new category of companies that are called carbon removal or CO2 utilization that are using this new type of science called CO2 mineralization. It's actually not that new, but it's being harnessed in a way right now that can have some real impact in the climate space. And ultimately, as the built environment doubles over the next 40 years, is we can't keep doing it the same way, whether it's steel or concrete or even timber, is like we need to be thinking about things differently because we can't lock in all these emissions. We have to do things differently, and companies like ours need to work with all points of the value chain, including producers, but end users, governments, specifiers, architects, to be able to change this course that we're on. Thanks very much.
Great, excellent introduction. So finally, turn to Michael. You're an architect. I wonder if you might reflect on these materials and how you use them, and also tell us a bit about your work with wood.
Right, great. So hi, everybody. So my practice is in Western Canada. I started my career with a guy named Cesar Pelli on the east coast of the States building the tallest buildings in the world. They were steel and they were concrete. And they were amazing because what those two materials could do is incredible. On the other hand, as we are talking about, they also have these huge carbon impacts. So when I moved back to Canada, Western Canada, I moved to the Great Forest of British Columbia, and I started looking at these huge trees and starting to think about their potential. Now, wood, as a tree grows, is giving us oxygen and it's soaking up carbon dioxide, and that's why the world's forests are so important to us as part of our climate solution, and protecting our forests is really important. But if you cut down a tree and you put it into a piece of furniture and into a building, you're actually storing that carbon for the life of the building or the life of that furniture or whatever it is, permanently in that structure. Now, as an architect, I look at the different building material choices I have, much like going to the grocery store. So when I go to the grocery store, maybe like many of you, I can pick from steel, concrete, aluminum, all these different choices. And what I've sort of come to learn is that much as the grocery store, the middle is all of the sort of man-made products of the grocery store, the highly processed food that we've eventually learned is maybe not the healthiest, and the edge of the grocery store is where all that natural food is, the meats and vegetables. Well, I think about building materials the same way. I want to be around the edges, and majority of my buildings built out of organic materials, materials grown by the power of the sun, not because I put a piece of green energy between it and the material, in the making of the material, but literally because the sun actually makes that material with photosynthesis. If I do that, I dramatically reduce the carbon footprint of my building because I'm using organic materials and especially wood. Wood, about 1 cubic meter of wood stores 1 ton of carbon dioxide. So that's 2,200 pounds, metric tons, so that's 2,200 pounds in imperial. So it's a huge sink. And in fact, the best way for me to make a carbon neutral building is simply to build it with a wood structure. So many of you are probably thinking when I say wood structure, 2x4s, 2x6s, the kind of material you see at Home Depot or Lowe's, and like any single family house would be built in. And that's true, that works. But really the game changer is engineered wood. And now what we have is a product called, or a series of class of products called mass timber. These are small trees cut into small pieces of wood, glued together at different angles to make giant panels, 60 feet long, 12 feet wide, of different thicknesses that allow me to build skyscrapers. And so about 20 years ago, we, in my office, developed a whole new way to build skyscrapers all over the planet using this technology, storing carbon instead of using these high intensive carbon materials like steel and concrete. Now, I am a huge fan because I need to still use concrete and steel. They're not going away. They are important ingredients. I just want to use a little less. And when I do, I want to use CarbonCure and other solutions like it. So that's the thesis of why I choose wood as a practice. So my practice only builds in wood. We built some of the biggest buildings in the world in wood. We're doing huge new offices for Google, for instance, in California, if you drive by the campus. And many of the big Silicon Valley companies are now endorsing this idea. The United Nations is endorsing the idea that we need to move to these timber buildings as the future. I'll get into fire with you and all the questions that are probably running through your head because this is the first new way to build a skyscraper in a century and people have a lot of questions. But it's safe, it's durable, but it has to be from carefully sourced wood that doesn't somehow degrade our forests. And that can be done when we source from really sustainable forestry practices. It also can be a disaster if we don't source from sustainable practices. So we'll get into this in a little bit, but different cultures around the world use different building materials for different reasons, and different applications like what I advocate doesn't always work in every application around the world.
Can I actually just pick up on a point you said there, like the grocery store analogy?
Yeah.
Like when most people go to the grocery store and they pick out a box of cereal, they look at the price and then maybe you look at the nutritional label. When you're selecting materials, you get the price, but you don't get the nutritional label.
Right.
And that I feel like if there's actually only one thing that I could change, if I lower my expectations, is just to have that information available so people like Michael can choose the right materials, and these are called environmental product declarations, but at best right now when they're available is they're 5 years old, and they may have been based on a set of circumstances. Yeah. The worst is the average, but even if they are facility specific, they're outdated the day they're published. So that makes it extremely difficult for people, whether it's governments or architects, when you're building a bridge, to choose the right materials. You could choose the same material, but from different suppliers even, is you need to have that information. And that's, I would say, one of the most important inhibitors right now of change, is if that information's not out there, you can't harness the power of procurement.
If I could add to that, there's, on top of environmental product declarations, there's environmental building declarations that take that entire package of a building and basically slap a label on the side of it. Yeah. That's really important because many of you have heard of LEED, many of you, or other systems that we use to kind of measure the sustainability of buildings. The problem is those systems are really incomplete in giving you the full picture of how a building performs. Yeah. And so you can have a sustainable building with all kinds of crazy unnecessary space and volume and character that you might think looks good, but actually has a wildly excessive carbon footprint and energy footprint simply because it's overbuilt, but it still gets a LEED Gold or LEED Platinum status. And so those are truth in advertising that prevents the greenwash that we all deal with every day and trying to fight our way through when we pick things.
Well, I want to just first say, please be thinking of questions. We'll get to them at the end. I want to just ask maybe, Margaret, if you want to close out this thought about transparency and, what is the right way to get transparency in building materials to your mind?
Well, the right way and the fastest way would be to have mandated EPDs, facility level. That would be a dream, to have like the, Energy Star of embodied carbon on everything, right? There is talk about kind of, and plans around kind of a voluntary way to do that within the federal government. What has started to happen is that customers are demanding that. So the more that clients, be it a real estate firm, the federal government, which we'll talk about, or even beyond the built environment, car companies, starting to mandate that as a part of what they're asking suppliers. And so that's what I've been pushing customers of these materials to do for several years, but the fastest way would be mandated. And so we can talk about Buy Clean and stuff like that. There are a few tools out there. Building Transparency is a group out of the Northwest. They've been doing this they have something called the Embodied Carbon Calculator, which they developed with Microsoft, which does a little bit about what Rob is talking about. Kind of basically you get that GHG nutritional menu and you can design around the numbers you have, but the information is incomplete, it's insufficient. We need some mandates, we need some major drivers as well.
Okay, do you want to come in quickly?
Yeah, just really quickly. I think Rob said it well, which is that the other challenge with some of these regulatory things or these tools is that they don't reach the parts of the world where the vast majority of building is happening. And that's our other challenge here, is that we need the solution so quickly. So a good stat to understand is that in the next 50 years, we need to build one New York City every month for the next 50 years to meet human need and human demand. And that's not happening here in North America, right? That's happening in the parts of the world where these regulations don't exist, and therefore industry has to find the tools and the innovations, I think Rob's work in particular shows that will leapfrog any government in a more developed world, their ability to kind of meet these needs.
Can I challenge that assumption?
Sure. Please,
okay.
Go ahead.
I will challenge that assumption. We talk about projections, right, and what the IEA says and what we anticipate being built. But we still have a lot of choices about how and why and even if we build. So core to the solution set of what we're talking about is whether or not we build new, how we build, with what we build, letting communities determine the direction of what kinds of materials they use based on what's available locally, about cultural values. But we do know that we're a pretty path-dependent culture globally. And so that's going to be part of kind of what we're challenging over the next many years is everybody going to grow just like us, or are they going to be smarter than us? Let's hope that they're smarter than us.
Right. Well, I think I want to move, and we can get into these things later, but it is an interesting tension that you raise. But I want to talk a bit about the picture in the U.S. with regard to procurement. The administration has faced a whole bunch of roadblocks in terms of implementing climate policy, but they would cite procurement as a spot where they've actually made some progress. And so I want to just get your perspectives about how much of a dent can procurement make, or how much can procurement catalyze the work that you're doing, and then are you seeing the effects, in your business and your work already? We'll start with Rob.
Yeah, when people ask, how do you see the path to scale? It's, to me, two things. One is the power of government procurement, and two is carbon markets. And carbon markets we can get to later, but it's also an enabler of some of this access to data to create automated EPDs, but that's a different topic. But on procurement, it's everything. Like, government purchases 40% of concrete. 40%. Single largest buyer. Easy. So government doesn't need to tell private sector how to buy concrete or other materials, especially concrete, is they just look at their own operations. They own those budgets. And if they make EPDs a requirement, if they put some kind of a carbon standard or some kind of some sort of motivation, there's different ways you can do it. it can really move the dial. Because once a concrete plant adopts these practices and technologies, they don't go back and forth. It's like, oh, it's a private project, it's a driveway here, and then tomorrow it's a bridge. Is once it's in, it's in. And most of the time, that actually saves them money and makes them better products and definitely makes them more efficient. So it's an extremely powerful tool that can be used, and one that we've seen firsthand have an immediate impact. And I'll tell you a story. Like, my first foray into policy was in Hawaii. Really great set of partners there, Elemental Accelerator. And they had those relationships with the communities and these governments, and they talked to them about this opportunity and what they could do with their own procurement power. It started off with the city of Honolulu. It quickly went to the Department of Transportation, then led to a state level legislation being passed. But over the course of like 6 months, the entire concrete industry flipped. And then, of course, everybody else, like New York State, Low Embodied Carbon Concrete Leadership Act, and many other states, they start falling like dominoes. And many other cities have also followed suit of what Honolulu has created. So like, there's this real shift, this policy shift right now, which is like common sense policy that does not require price premiums. It just it sort of challenges the material suppliers to provide them a lower carbon product. With the 600 producers that we work with, they could all do things lower carbon. But most of the time, either they're not allowed to, that's called a prescriptive specification, so that's a terrible reason not to, or no one asks. But if you just ask these questions and actually build it into the specs, then all of a sudden, they're more than happy to oblige. And maybe then the next time you do a project, you push them a bit further and say, okay, that was nice yesterday. I want you to do more. I want you to challenge you. But this can really get going and create a snowball effect.
Well, I want to throw in one other detail, and either of you can come in on this, but or rather one other, take it a little different, is buyers alliances, private sector actors that are creating that market signal. And I would just, you can comment on government procurement, but how are the private sector private sector buyers alliance shaping the market? And any of you can come out, any of you can come in on this.
I mean, we can talk about kind of the big one that the White House rolled out at COP last year, which is the First Movers Coalition. This is really thinking upstream and downstream, trying to get buyers of these low embodied carbon materials from the private sector organized and basically kind of either buying what's existing there, continuing to improve that over time, or starting to require it in, kind of sunsetted in horizons over time. So we have folks like some car companies, some major technology companies. So doing a little bit of what you probably have read about in Sweden, which they've gotten basically promises to purchase future green steel. They started with steel with the First Movers Coalition. They've expanded to concrete and aluminum. So this is a good example of that. There's other examples like Steel Zero, which the Climate Group has had for a few years, which is working on basically creating a procurement pathway for low or zero carbon steel in the private sector. It's going to be a really important tool. But government being able to, with the Bike Lane Task Force, which the White House also rolled out this last year, which is going to be a really, really important tool to leveraging the power of the Government Services Administration, the GSA, Department of Transport, to use all the federal buying power we can and create these pathways and the technical and the feasible and the business cases across the country to make this happen. So I think both of those are going to make huge, huge dents.
Well, I'll shift gears a little bit, and we're going to go to questions in 5 minutes, so keep thinking of those. But to ask you, Michael, or we'll start with you on this one, but obviously in any industry there's a fair amount of inertia. People are used to doing things the same way that they have done that. How do you generate a cultural shift? How do you get people to open their minds, a customer and say, hey, or client and say, hey, there's a different way to do this?
Right. It's, that's been an interesting path for me personally, because when we first came up with this idea of the wood skyscraper, my peers thought I was an absolute idiot. So it took a while to get some mobility with it. But the answer is really interesting, because in different parts, even throughout the United States, I don't know how much you all appreciate this, but from location, city to city, they're completely different building trends that happen. So for instance, in Vancouver, where I live, we build concrete towers. In Seattle, they mostly build steel towers. Those are cities only 2.5 hours apart, but the cultures of building are quite different. And so to ask them to flip, the industry is really resistant, even to flip using conventional materials that they should otherwise know lots about. Those become these deeply ingrained traditions that are hard to change. With the work we've done with wood, it's been remarkable. The fact that building codes around the world have changed to allow what we've been talking about, that the material industry has grown around it in a very short period of time. And a lot of that has been through government advocacy around the world, certainly the support of the IPCC and other organizations speaking about this. And then the curiosity architects have in just trying new materials and wanting to promote the ideas of new materials. It helps for me that wood is extraordinarily beautiful, so people tend to want to use it anyway. I think the big question for me personally that I'm really interested is in what's next. So there are 4 major structural materials in the world. Typically, these are the volume of our materials: steel, concrete, brick, and wood, or masonry and wood. I'm really interested in what's 5th. And what's next? Because we're talking about taking our existing technologies and just trying to make them better. The question is there a 5th? Is there something next? And I think biotech will be the answer to that. Much like we're seeing food revolutions happen around biotech, we're going to see the same thing happen in the building industry.
Rob, you were talking about conversations with some of your potential customers and what's driving their decisions. Do you see any cultural inertia that's keeping them from using your services?
I think everybody would like to be green if it didn't cost them anything. I also think that if it's really easy, and I was in the session earlier about the pathway to behavioral change is through ease. And I think if you can show those 2 things, there's very little resistance. So it can't, as producers are awfully gruff, they'll say like, hey, don't screw up my plant, is what I hear when we're first installing the equipment. But if we can prove to them and then they share that with other producers, and there's a strong network there that share a lot of best practices, then it starts to become more common practice. And now with so many plants across the US, it'd be hard not to find a CarbonCure concrete producer in your city, is that it's becoming easier and easier. But that's just the US. And so now we need to be creating those beachheads and creating that trust and showing the economics, showing the environmental impacts at so many other regions all at once. Like if we're gonna have an impact on climate in the time frame that we need to, my challenge is not necessarily the mindset of a producer in the US, it's like time, right? Like how do we race against the clock to be able to have the kind of change which goes at the pace of building trust? So how can we do that in parallel at scale?
Well, that's a consistent theme that's come up, thinking about beyond the US, how do you advance adoption and have those conversations. Let's take some questions. Okay, we can go these 2 and then 2 at a time, these 2, and then I'll come up to you 2.
Sweet, we get lots of questions. This is good.
Yeah.
Lots of hands.
Yeah.
Thank you, guys. I'm a real estate owner, not a developer, but own commercial properties. And at the end of the day, it comes down to price, and the price can be nudged by the government or not. But today, absent additional incentives, curious, I guess, for each of the 3 of you guys, what's the incremental cost of a mass timber building, maybe not a skyscraper, but a mid-rise, and incremental, cost for a yard of concrete and for steel that comes out of a plant that, relative to the traditional methodologies?
Okay, and then maybe if we just hear this question so we can expedite.
A question for Michael. What is the structural integrity and longevity of the wood, and how tall can you build a building with wood?
Great.
I want to do that one quick first. So we actually studied the Empire State Building as a template to see if we could have built it in wood, and we proved that we could have. We could engineer it in wood. We do sometimes use steel. We certainly use concrete in the foundation, but we can build very, very tall. Whether you should, that's another question. I'm not actually a believer, ironically, in tall buildings. I think after a certain point, they become like socially disconnected people, and they don't make better cities. So I tend to advocate up to 18 stories in wood. It's strong because it's engineered, glued together, and that makes the materials very light. So wood is 1/6 the weight of concrete, 1/4 the weight of steel. That means you're not, in fact, when you build a concrete building, an enormous amount of the concrete is going into the building to support the weight of the concrete. And so wood is actually quite efficient from that point of view.
Incremental cost, do you want to?
Cost, depends where you are. The answer on cost is the industry's young, the mass timber industry. It can be very cost competitive in certain markets and less so in others because it depends on expertise, distance traveled. There are many more producers now, just in the last 3 or 4 years in the United States. That's dropped the price. But the cost of timber is doing the crazy commodity thing. And the truth is right now we're all experiencing it. The cost of construction has just gone through the roof, 30% up in most places that we're building right now.
But if you happen to be building near a mass timber facility, you're going to handle what's the relative cost?
So yeah, I don't want to get in the weeds, but when we can be dollar for dollar equal to steel or concrete if you design it well and you start from the beginning thinking it's a mass timber building. You don't swap it in later because that's inefficient. The efficiencies in speed. A lot of it's in speed of construction and quietness of construction. There's a whole other kinds of ways we measure costs today that's different than the way you used to around just project cost or construction cost. You want to do concrete?
Yeah, for CarbonCure concrete, it's the same price. And the way that you do that is that you actually require less cement to make concrete of the same performance. And that's why it's so important when you add CO2 in a way, you're creating this nanomaterial which increases the strength of the concrete. So then, as an engineer, they would specify, say, a 30 MPa mix, and then if you're giving them 35, well, they don't want 35, they want 30. So then the producer is then able to optimize, gain some efficiencies by pulling out cement. So that allows them to pay for all the technology and cost of CO2. So that's really, really a key point, is I think price parity needs to occur for us to see really scalable impacts. And that's not just in the US, as we can show that you can provide price parity concrete. We're operating on all continents on the planet now, and we can show that in every location.
If you're talking about a car, let's talk about, it's a little easier to talk about a car. $400. That's what we're talking about. You're going to debate more over your heated seats and your color, right? Like, that can be spread across the supply chain. And there's a lot of ways to deal with that at the upstream with things in policy designs like carbon contract for difference. People are even internalizing that among their customers and thinking through how to do that absent policy. Buildings, probably, it depends on what's available. Similarly, if you pick, EAF and 100% renewable electricity, it's talk to your suppliers ultimately. Set the specification, increase performance over time. It's very doable.
Steel right now is the highest cost for us to build with, hands down, for buildings right now. That's unique right now. It'll change in a few years. So certainly that's what I'm finding is steel's the most expensive option.
Great. So we had 2 questions up front that I had signaled I would take if we still have
One back there.
Mike.
David, over the years, glues and sealants have been notoriously bad about outgassing. The new glues that the plants are using, are they working on making those materials more environmentally safe?
Yeah, so it's a great question. So they still off-gas there's different glues you can use. The polyurethane ones are actually pretty good. There are glues they're using to get the longevity that aren't great in the factory, but afterwards they don't have VOCs, so they're not off-gassing once they're in a building. We've all been surrounded by these engineered wood products, all of our lives. They've been around for 75 years as glue lam. They just now are in these new panels. They can be burned and they're safe when they're burned, but mostly these materials get reused, and that's another part of the story is they become part of a circular economy, and they just go on being reused and adapted over time, which is much harder to do. Possible in concrete, possible in steel, but a little easier in wood.
Okay. Okay, I want to come to you because I said I would. So is there anyone else? We'll go to one question in the back, or right in the back, and then we'll come up to you.
I'd be terrified of living in a high-rise that's built out of wood. because of fire risk? Could you just address that?
Sure. So the buildings have to perform the same. So the level of fire safety in a tall wood building is the exact same as it is in a concrete or steel building. The way we do that is a little bit different to achieve that. I mean, if I ask the room, how many of you live in a wood frame house? Probably almost everybody. And we don't all get concerned that the house is going to burn down every day, right? It's because we can protect it. We know there's technology to protect it with drywall and other ways in a house. We do similar things in these big buildings, but the best way I describe it on fire, that the easiest way to wrap our heads around it is the scale of the wood is so big. It's a little bit like if I handed you a log and a match and said, go make a fire, you probably know you can't get a match to get a log on fire. You need to start with tiny things and work your way up. That's the same principle. These buildings are so massive in the wood scale that they just can't really light on fire very well. And the few occasions they have, they actually put themselves out on their own. They don't even need sprinklers. So the few big examples we've seen of fires that they just kind of extinguish because they can't gain enough surface area.
Great. Okay, up here.
So we talked about 3 building materials, cement, wood, and...
I think if you lift it up, yeah.
So in terms of building materials, cement and wood and concrete, but how about glass? That in some houses, they take like 40% or 50% as building material, especially if it is waterfront or something. So is there any particular aspect of glass that requires it to be innovative or different?
Great. Is that?
You want to take that?
I can do it. So absolutely, glass is a high energy material to make. It can be recycled, which is really good. We're getting into all kinds of coatings that honor glass to make it higher performance. That makes it harder to recycle. So it's an excellent question. Aluminum was mentioned earlier by Margaret. That's a very high carbon material, and we use it in almost every building for the window systems because it's in commercial buildings the most durable. So there are many other materials that do have a high footprint that we have to consider. Our focus here is really in the highest volume materials, which is what the building structure itself is. That's the dominant material. I think the statistic is that whereas the building industry represents 40% of global climate impact, man-made climate impact, the building industry uses about 50% of the world's natural raw materials, and so it's an enormous amount of material going into it, and most of it's structure.
Okay, maybe one more question. Okay, right here.
Thank you all. It's been very interesting. And coming from Ohio, I've got to ask, are there any particular arguments that you, or just ways of approaching the coal miners that you think might educate this population and help bring them on board to more environmental and better living kind of concepts? So rather than, generations of families that have been in the mines, and that's just all they know and the only way they know how to live.
Yeah. I can talk broadly about kind of labor and just transition. And I think having an open, honest conversation with folks who, whether it's the extractive industries, the actual production of iron and steel, or other materials, we talk about, conversations with steel workers, iron workers, everybody has to be involved in this conversation. I think that it's inherent on good policy to think about the controlled descent of the fossil fuel industry, and that folks who have paid probably the tallest price personally by breathing in this stuff every day deserve not only a good place to land, but also the idea of honoring the legacy of what they've done in terms of creating local economic opportunities that are high-paying, quality, union competitive jobs in those local areas. So I think, I mean, you can think of some good examples of how this has worked, and Illinois is a good example of some of the just transition in terms of making sure that the benefits are felt locally by folks who've been impacted most by fossil fuels. But I think well-designed policy addresses that. I think politically, we do have a retail politics problem. The Biden administration has done a really, really good job. I will give them credit for having really smart, savvy global policy on this, integrating trade, integrating economic outlook, integrating the geopolitics that we're facing right now, which are essentially is a new Cold War, right? And that green steel has to be at the forefront of that. But ensuring that those jobs are staying in communities that have benefited economically from that kind of industry, and bringing more people into that, because not everybody has been a part of that, right? And so I think it means concentrated policy, thinking through how to locate some of these new production facilities, be it green hydrogen production, DRI production. Specific example in Ohio, there's a company called Cleveland Cliffs. They bought about all of Arcelor's old steel plants, right? They have mines as well. That's a company who's vertically integrated, and they're well positioned to think through exactly how to make sure the felt needs of folks who are already bound up in the industry and the communities around them are systematically addressed by making sure that clean steel production remains in places like Ohio and Chicago, where I'm from, and throughout, I think, kind of traditional Midwestern states.
Well, with that, we have to close. I have to say it was a great discussion from the background to the role of policy and procurement. Thank you very much to those panelists.